So what is electric current? Well, so that's what I'm going to try to answer. Okay, if you are studying physics and you're getting into electricity and magnetism on the introductory side, so maybe grade 11, grade 12, or introductory college or university levels, you're going to be wondering what this current is all about. Well, so first of all, okay, you have actually kind of thought about current in many different ways. You know, if you think about current in terms of a river which is flowing through, you kind of know, okay, the idea of a current. Well, when you start talking about charges, okay, and the charges are going to be flowing, well, it's the same idea. So, you know, if I point out here to a faucet, okay, which is draining water, well, we can ask the question, so how much actual kind of water is flowing out of the faucet, right? And in that case, we can also call that, you know, volume flow, okay, or current flow. Well, in this case, if you're going to be talking about the flow of electrons, okay, from one point to another, you can again ask the questions, okay, so how many electrons are actually flowing? Now, current in general, okay, so is defined in the following way. So as you can see there on the screen, so it is designated with the actual symbol capital I. Now, it's designated with a capital I, and that goes back to the person, okay, who kind of studied on the original sense, okay, or one of the persons who studied on the original sense, current in general, okay, so the electric flow, and wanted to find out what is the intensity, okay, of that current flow. So that word intensity, I, kind of has been adopted, and we utilize I as the current in electricity, so kind of where it comes from. Now, that person was ampere, okay, and we also, okay, in designation, okay, of ampere, so of the person himself, we give him the standard SI unit, so the metric unit for actually current, okay, which is amperes, or amp for short, okay, or amps, okay, as people use that, and I'll write that out in just a moment. Now, that current, as you can see there on the screen, is nothing else but simply the amount of charge, okay, that is flowing over a certain amount of time. So you may recall, well, you have done this in quite a lot of different ways. You know, one of the original, okay, rates that you have been talking about way back in kinematics was actually speed or velocity, right? So how much distance are you covering, okay, over a certain amount of time? Well, so this current is exactly the same thing, except, you know, you're not really talking about how much distance you're covering, okay? Or if you're talking about water flowing, you're not talking about the amount of volume, okay, that is flowing out, but you're talking about charges. And that particular charges, okay, we want to be able to see, you know, how much charge do we have per a certain amount of time. So, you know, how fast, okay, are these charges passing us by, and how many really charges are passing by, so let's say per second, okay, or so on. Now, if you are looking at this, so in general, so the Q is typically measured in coulombs, and then the actual time in metric standards is typically measured in seconds. So coulomb per second is the metric standard, but okay, we have designated, as I said, so this is after amperes, or amps for short. So amperes, okay, or amps is nothing else but coulombs per second. So that's what we have right there. Now, this idea, okay, of water flow and so on, you know, I've kind of designated it also with respect to voltage, and I put up the voltage equation. You might be wondering, you know, why did I put it up here? Well, this is just as a reminder, you know, so we first, okay, or at least I first defined voltage, okay, and gave you the idea, you know, how much, okay, of a difference potential you might have. And you actually do need that difference of potential in order for current to be flowing from one point to another. So for instance, if you have a battery, okay, and this battery, let's say, is positive and negative, so you have a certain amount of voltage, okay, drop over this battery. So in between, if you start to connect this battery, okay, so here's a conductor, here's another conductor, okay, and maybe you're going to be conducting it to some kind of a load, okay, so within here, now load can be anything. It can be, you know, your light bulb, for example, it can be your fridge, it can be, you know, this computer, cameras, anything, right? And you basically can allow current, okay, to flow. Now, that particular current okay, although we talk about coulombs, now please remember that the flow, okay, of these charges really in these conductors that we have as we connect them through really boils down, okay, to a smaller and smaller level, which is really the electrons that are flowing. Now, what is interesting is that we've discovered electrons after, okay, we've actually set criterias, okay, or the actual kind of basis for our voltages and for our currents. So we didn't know that these electrons initially existed, but then later on we did find it. So, and what's interesting is something that you should know is that the electrons actually don't flow out of the positive terminal, they flow out of the negative terminal. And they actually flow, okay, in this direction. Although by convention, again, just for historical reasons, okay, and also for some practical reasons as well, we actually typically, okay, when we are drawing things out, we're going to say that current I, flows out of the positive and it goes, okay, into the negative, right? So that is a positive convention. But technically, it's the opposite that actually happens with respect to the electrons, okay, that are flowing. Now, this won't really cause you any impact in terms of doing math or anything related towards the calculations themselves, but it's something that you should know, especially if you're going to be heading on maybe into, engineering, okay, maybe you're studying health, okay, or something like that. You should know that, electrons are actually flowing from the negative to the positive within here. And it is the electrons, okay, that are carrying the charges that you have. Right? So overall. So if we have this equation right here, not very difficult, okay, so how much charge do we have, okay, per a certain amount of time. Now, if you would zoom in, so I'm going to kind of take this, let's say take this conductor, and I'm going to zoom it in, right? So I'm going to really zoom in into this conductor. Well, what is happening overall is that when we are talking about current, okay, so initially what you should talk about, so these are typically designated, okay, as just electrons, okay, so these electrons are going to be flowing through. Now, of course, okay, I'm only going to draw a few. So if they are moving, okay, in one particular direction, right, so or they're just flowing in one direction, that is called direct current. And you maybe have heard of this, and all batteries work like this. So this is direct, this is the D, this is the C. So DC current, right, which really just means direct current, means that the flow of the electrons is just in one direction. And initially when you're starting this off, that's what you're going to study, right? Now you might be thinking about AC, right? You maybe heard of AC current. That means alternating current, where the electrons actually can flow back and forth. Now, there's a reason for that because actually the electric field and the voltages are swapping and they're changing. So the actual electric field is changing overall. Now, you don't have to know that. For this video, what I would want you to know is to understand direct current, which is the starting point of understanding, for example, circuits and currents and working with voltages in general. All right, so direct current or DC current means, and it tells us that the electrons are flowing in one direction. All right, so there you have it. So basically these electrons are going to be flowing in, okay, or flowing out here. Now this isn't connected to anything, but if it was, right, so this would just kind of flow out in this particular direction. But by convention, all right, we assume that current, okay, and you're going to see this, now this, you might think that, boy, this is going to be confusing, right, where current is actually shown to be flowing from the positive to the negative. And when we're calculating current, so when you calculate this, for example, if you say, you have a certain amount, okay, of electrons. So let's say that we have, for instance, 1.5, okay, coulombs of electric charge, right? So these would be electrons. Now this is going to be a huge amount of electrons that are packed into all of this, right? Now think about it, because one electron has a charge of 1.6, times 10 to the negative 19 coulombs. So, this is going to be quite a lot of electrons packed in there. And now notice what I've done is I did not include the negative in here, because of course the electrons have a negative charge. But when we start to work with circuits, we actually drop it and therefore it allows for the convention of positive to go through. So for instance, if you wanted to calculate what the overall current is, so let's say, what is the current, okay, of this many electrons flowing, and this is going to be a gigantic amount of electrons flowing, let's say, you know, in 10 seconds, all right? So for instance, that's how much time. Well, so you would go back and you would take, okay, well, what's the charge? It's 1.5 coulombs. You would divide it by 10, okay, so this would be 10 seconds, and you would have gotten 0.15, okay, this would be coulombs per second, or, you know, moving forward, you're going to be starting to see this is going to be 0.15 amps, okay, that's actually flowing through. And notice that it's positive. I did not put here a negative, although obviously I am talking about charges with respect to negatives, okay? Now, if we put the negative in there, notice that the convention, so now this is positive 0.15, so what we would have is we would have current, okay, which is flowing, so let's, you know, create a wire in here, okay? So we would say that, okay, 0.15, okay, amps is flowing in, and this would have been the convention. But technically, right, it goes in the opposite direction, where the electrons are actually flowing back in this direction, okay, because of the fact that they flow from the negative terminal to the positive terminal. But in terms of definitions, we do not put the negative inside of here. We talk about charges, okay, that are positive, all right? So it's the positive charge divided by, you know, the amount of time that passes by. And all it tells you is, all right, so how much charge has passed by per a certain amount of time, right? So that's what we would have in here. So that's the definition, okay, of this electric current. Now, I've mentioned the direct current, right, where the charges are flowing kind of in one direction. They're not AC or alternating current, which would mean that they would be flowing back and forth, okay, and it'll be kind of oscillating back and through. So you eventually are going to get there if you keep studying, okay, electricity and magnetism. But in the onset, you typically study direct current. So for current, when I'm referring to it, okay, I'll just mean DC for the moment, okay, as you're going through. So now, you should know, okay, so for example, in terms of batteries, you're going to slowly get into, okay, kind of the concepts of how to provide symbols for these, right? So for a battery, you know, very often instead of drawing batteries, okay, as I have over here, you know, we provide a symbol and we just simply say, okay, this is kind of positive and negative, so from a positive to a negative, right? And this is the symbol for a battery that you might run into, okay, as you're drawing it out, because we don't want to waste our time drawing out batteries, right? And this would have been known, okay, kind of as a DC current battery that would provide you. Okay, batteries also have a certain voltage, right? So in terms of that, I'll put up a link, okay, up above there on the voltage side. So if it's 12 volts, 5 volts, 1 volt, whatever it might be, that just gives you what the actual electric kind of potential difference is, okay? That is voltage, all right? Okay, so this is the introduction to current for you. Now that you have known, okay, both voltage and current, you can start to begin slowly, okay, the construction of various circuits, okay, and start to figure out, okay, how these currents and voltages can be calculated across various loads. So thanks for watching, okay, and we'll see you in future videos. Bye, everybody.